Welcome, everybody. We're going to be working through the Chapter 6 exercises here today. We're going to start with exercise 6.1 that you can see on my screen right now. And this is basically learning to work with a list. I do want you to notice that we're going to be working with random integers. So we're also going to throw in a random number generator here. So I don't know if that's a first for us here, but I'm pretty sure it is. So that's a new concept as well. And then we're gonna try to, once we have a list built randomly, do each one of these tasks inside the program. All right, so that's kind of the lay of the land. I took that set of instructions and copied it. I'm going to be working inside a Spider here today. I have all my old exercises open, so let's do a close all on those. And the first exercise is 6.1, so I'm just going to do a save as. And kind of use my storage conventions here to store this. Looks like we need a new folder. This will be unit 6. And as I normally do, I'm going to entitle this X6_1. And really, you could call this whatever you want. This makes sense to me when I'm looking for them later, like because the chapter and exercise number are built into the file name. I'm going to zoom in a little bit on both panels here. So this is the code panel and the console. I want to respond, but there it goes. That's interesting. I had to use the number keypad plus sign in conjunction with control to make that zoom. I'm not sure why that's the case in the console here. All right, I'm going to take the instructions that I have and I'm going to paste them up here at the top just so we can refer back to it and I'll have to flip to that document. All right, let's start first by addressing the issue of how do we get a random number generator. And if you guys look really carefully in the book, there's a spot, and I don't remember the exact chapter number, but I want to say it's, I think, chapter 3 maybe, where they first introduce it. I don't really emphasize it a lot back then because there's not really a lot of usage for it at that point in time. But now we have a direct call in one of the exercise instructions to use it. And a random number generator is actually kind of an interesting thing because when we do things in coding, what we're often doing is hoping to get the computer to simulate the randomness of the real world. And so people actually created software tools to do that. And they're not directly built into the core of the language. So, I can't just say, hey, give me a random number. I actually have to import the random number generator from a special library. Now we're looking for one particular tool within that library. All right, so the library is actually called random. So I'm going to start by saying from random, import the specific tool called rand int, and as it sounds, it generates random integers, right? As opposed to floating point numbers or something else, right? So think about this. If you were to code a video game, maybe that simulates dealing a deck of cards or rolling a pair of dice, you wouldn't want the computer to stack the odds against you, right? By like controlling what's coming out. You want those numbers to be random. And that's why these tools are useful. It's also very helpful in doing things like probability and et cetera, statistics and stuff. But in this case, we're just trying to get some random numbers put in to the program, basically. All right. So this is the first step. So we do our imports. Usually when we write our code, we do those imports right at the top of the program so that the rest of the program can access that tool. All right. Okay. So let's take a look here. And it says, write a program that initializes a list with 10 random integers So we're going to need a list. All right. So let's talk about this. And we kind of looked at this in the Kahoot a little bit. I kind of wish I wouldn't have done the Kahoot the other day because it would have been kind of a nice lead into this. But when we develop a list, the concept is basically that instead of having a bunch of variables, each with their own name and each going into their own memory space, we use one name to hold a bunch of values that are related. And then we use their index values to access the individual members of that structure. So when we were doing that like little thing in Excel, I don't know if you guys remember this, but we have like this concept of um, all the little letters of a string, for example, have index numbers. Same thing, right? The string is stored in one variable, but each character really is separately accessible in a string. That's one of the capabilities of a string that we don't get with a number. So if you even think back to the chapter 5 stuff, we were taking numbers and converting them to strings just to isolate individual numbers in the number, right? And that the only way you can do that is with a string, because a string really is a complex data structure ultimately. So it becomes a really good example sort of a list, right? Or any collection of data. All right, so let's create an empty list that we can put stuff into. I think that would be helpful. I am kind of like pushing this down a little bit on my screen um, because I plan to insert something else above it, basically, if you're wondering. So why don't we just come up with a list and give it a name? I'm looking at my old solution here, and last time I called the list values. And then if I want to create an empty one, all I have to do is use square brackets. So I put in a left and a right square bracket. And what this does is it just takes a spot in memory saying, hey, there's a list coming here. Right now, there's nothing there, but save this space for it, right? How big is it going to be? We don't know yet, right? Well, we do. You know, the thing that we discovered is that it's 10, right? We want to make it the size of 10. If I wanted, so I'm just going to kind of show you, if we're not using the random number generator and I wanted to have what seemingly was a random list of integers, I could actually just type them in here. So I could do like 3 and 4 and 45 and some bigger number and etc. Um, I think you get the point, right? But you could type them in like this and then notice that you're comma separating all the values. And then each value inside here, just like a string, we can access through an index number. The index number would begin at 0, and then we start counting 1, 2, 3, etc. Right, but we're told to make this random, so this is not random; it's human controlled. So I'm going to get rid of that stuff. So let's go back to a blank list. But I do want to show you that. So that's one way you can create a list and put stuff in it immediately, and it's stored. Right. If you remember back to the readings in the Kahoot, there's also ways to add stuff to this and remove it. And one way to add values to this list is to just do something very simple, like say values dot append, and this is a function, mind you, and then I can take whatever it is, if it's a number or a string, right? Um, use letters for a string. And what that would do is it would take this value and drop it in. Since the list is empty, what happens is this is in the first position. So it's in index position 0, right? Now, I'm just going to do a little demo here on this. So this is kind of sort of lecture. It's not really on topic for solving the problem, but I just want to show you a little bit of how this works. So right now I created a list. I'm appending a value, and this is a string, so it's just going to be nonsense. And then I can output it. So look, check it out, right? And there it is. Now look how it outputs, which I think is kind of neat. Um, it outputs it in list format. So it gives me the square brackets and quotations around it to show me it's a string. And then if, for example, if I was to do another entry here, do another append, standard whatever, and we run this, notice that that appends to the end, right? So that's a really important command for list building. And we're going to use the append command to to add a whole bunch of values, and then we're going to get clever about it and put it in a loop, and then have the random number generator run a bunch of times and fill the list. Right? Kind of a clever approach, but you can do it manually too. That's kind of the point. So I'm going to remove these. But I will kind of just reinforce the fact that if you're ever trying to see, well, hey, what's inside my list, you can just put the name of the list in a print command and run it, and you can see, right? So that's a really helpful little aspect. Now, typically, I would just go right into writing the loop with the random number generator here, but I want to kind of throw in a couple of concepts. So the one thing that I like to do sometimes, especially if I'm experimenting with things, is instead of hard coding the count of 10, which because I'm looking for 10 values, I sometimes set up something like that into a variable and then inject the variable into my code. So then if I want to like ramp it up and go from 10 to 100, I can do that programmatically. And I'm going to say this is probably optional. So if you want to mark it as such, not a bad idea. This is optional. You can hard code the 10. Right. So I can just put the 10 right in my code. The only thing I'll have you think about here is if you take that value of like, hey, I need 10 values, and that call for 10 values happens more than once in your program, the variable approach becomes really logical because that variable can exist everywhere. Then you change one value to affect the whole program. So I'm reinforcing it as like, I think, a good programming habit. After I get this to work with 10 values, I think I might try upping it, maybe try like 40 or 50 or 100 or something like that. So we'll see how that goes. All right. So this is just an integer that's going to hold how many values we want, right? And maybe that's a pertinent thing to add here. How many values? Yeah, I'm doing that as a comment here. And you know what? Let's save the space a little bit. Now I'm going to come down here, add a little more code, and actually let's not do that here. Come down here to the bottom, and now we need to actually run a loop and add the random numbers. So we're going to learn kind of the random number generator here again. So I'm just putting in a comment so if you're keeping notes or whatever. I'm going to use a for loop to do this. It's my typical go-to loop for most things. We're going to do an I in range thing. So I know it's been a couple of weeks since we've done loops, but when we use this syntax here, this is a type of for loop that in most languages we refer to as a for each loop, which means it operates automatically with a little bit of control, right? And so why this is useful is without specifically knowing the size of the thing that we're dealing with, a for loop like this can automatically traverse the structure, right? When I add the range command, I control it. So I can set the starting and ending point. And so inside the range parentheses here, we're going to function over the entire size of this thing that we're building. The first position is position 0. So that's the starting point. We're going to run up to the number of integers that we want to create. So I could just hard code 10 here. All right. So, but think about this once again. If we are doing 10 values and the index number starts with 0, the final index number will be 9 because 0 through 9 is 10 values, right? It's just shifted over one. It's on our normal counting brain. And then if you remember how the range command works, it will never reach 10. So if I wanted it to have the highest index value of 10, I would have to put 11 in this spot. right? But the fact that Python goes one beyond is related to the list structure because we start counting at zero. That's the why, you have to, it never reaches the last value. Right. Here, we put in our colon, we come in and we indent, and then we're going to use that append command, and we're just going to simply say values dot append, two P's there, with parentheses, and then we would put whatever value here. Now, we want to trigger the random number generator. The syntax for that is the name of the tool is randint. So we're just going to call that. We'll say randint, once again, parentheses. And keep in mind, anytime we're putting stuff inside parentheses, that it's indicative that it's a function of some sort. So append is a function that works with list structures, right? Randint is a function that works with random numbers, right? And to control it, we put our values inside here. Now in Python, when you're doing random integers, we want to generate values within a range, right? So once again, how big or small do you want these numbers to be is really kind of the whole point. Let's talk about this number 10 here again. So right now, I hard coded the 10, which I said you could do above, but I'm going to switch it to the variable approach. I'm going to say num int. And that way, if I decide to make this 50, I want 50 things in my list, I can do it. So here, when I run the random number generator, I want to declare the range in which I'm generating random numbers. Now I could, kind of make this a really, really huge kind of thing. So I could go from 0 to 1,000,000 or something like that. Kind of silly. What the author originally did in their solution was they did this. And they're generating random numbers between 1 and 10. Why? Because they're easy to look at. I mean, that's just basically the answer, right? And it's really easy to see if they're even or odd. One of the calls that we have here is, every even index, every even element. So we'll try that to start with, but we could use something bigger. In fact, I'll experiment with it just a little bit. Okay, so believe it or not, that's going to, fill the list with 10 values. So it's going to cycle 10 times and then generate random values between the numbers 0 and 10 and add it to the list incrementally. It runs, it's done, and then, we move on, basically. Good idea at this point to test to see what happened, so here, let me drop in my comment that says exactly that. Test print to see what happens. So I'm just going to do very simple print command like I did before. I'm just going to print values and see what we have on the screen. And what I'm going to add here as a note is I'm going to say this is primitive. But it works. And sometimes you just want to see what the data is. You don't need to make it look pretty. So let's just run this and see what happens. All right, so here's the run. And take a look over here in the console and you'll see that indeed it generated 10 random values between 0 and 10. Let's experiment a little bit more, and let's just say maybe we wanted to go up to 100. Let's just see if that works. And there you go. So now you have values between 0 and 100 randomly. Right? Are they random? All right. Well, here's the only way you can really test it is to keep doing it. Right. So we'll just run it a few times, and are the values truly random? They seem to be. Right. It's not repeating. I have had a couple circumstances where I would do the random number thing, and I don't think it was with you guys, and it was this semester, I think with maybe my Java 1 class, and we were running the random number generator in Java, and it came up with the same result. And I remember the scenario, we were creating the game rock, paper, scissors, and it came up, the computer kept guessing the same thing that the user was guessing, and we're like, that's not random. And then we had to run a test to make sure it was actually random. It was just a stroke of luck, because when you do play rock, paper, scissors, you don't know what the other person's going to pick. And if it's it's a tie, you do it over again, right? So a lot to think about there, but whatever. All right, we'll stick with that 100 here. I think that that's probably more fun to work with. Um, Another thing that you could do, and this is probably a better way to do it, is in your print command, it's probably better to say something like this. So I'm experimenting with output here so you can see the differences. And we use our original print approach where it's a string, and then we use the comma to concatenate values. Let's run it like this. Let's see the difference. All right, well, it looks pretty much the same, right? What if we did the print command using that string interpolation that we talked about, where we use that letter F in there? Use your curly brackets, and then we just add values. Let's see what that looks like. Does that look any different? No, looks pretty much the same. I have been leaning a lot more towards this approach lately in writing Python code because it mimics what I do in some other languages. This concept of string interpolation, of just basically being able to drop the variable right into the string as you're outputting it, I think makes it both easier when you're a beginner, but also a little more elegant when you're a pro at it, to get things formatted. So generally, I think I'm going to stick with that approach moving forward. It'll depend, right? It'll depend. All right, so that was our test, right? All that stuff is a test. So let's just put in a blank print command here so that we have a separation between our stuff. And in fact, do a couple of extra ones here. I'll do another blank line there. Just want to show you the difference. This is just to kind of make things look a little nicer, easier to see. In fact, let's do it like that. A little more spacing. You know, and that's kind of a tip I give programmers too. It's like, you don't have to squeeze everything together. You can give it a little space and, you know, room to move out, if you will. Now we have to do the tasks. So we successfully created a list of random values. Every time we run it, it comes up with a different list of values. So that's working just fine. And we're only doing 10 values right now. All right. Let's address the issue of, and then prints 4 lines of output containing every, so okay, so this stuff here doesn't count. These are all test prints, by the way. You know what? You could label it. So you could say, or if you want, you could comment this out. Doesn't matter. Excuse me. All right. So the first task is display every element at an even index. All right. So just to review that concept, right? So when we look at this list here, the indexing starts at 0, right? So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 to 9. All right. So really what, like if we're looking at this list, what we want it to output is, well, is that an even index? Yeah, 0 is an even index. So, you know, this is where the starting with 0 kind of bends your mind a little bit. We start with even numbers, not odd in reality. So we would print in this scenario every other one starting with the first one, right? So what code would that take? Well, first of all, you should recognize that this is a repeating process. So a loop makes a whole lot of sense. Let's start by, oops, there. Let's start by just doing a little bit of information to the screen for the user running this. And we're going to say elements at an even index position. And normally I would just do the print command and walk away. But what I'm hoping to do here is I'm going to use the approach where we're going to just kind of add stuff to the end of the line instead of going to a new line. So I'm going to use the comma approach and the end equals with an empty string at the end of it. So what this does is it will print these words on the screen, give me a space, and then allow me to, with my next print command, to print the values right after this text on the screen. All right. And then when I do the print inside the loop, I'll do the same thing to keep all the values right there. So let's work on the loop now. Here comes the for loop. So we're going to stick with the for I in range because it makes a lot of sense for what we're doing. And here's where I'm going to stick with that from 0 to whatever our num integer is. Okay. And we can make this bigger. And you know, by the way, I'm going to, you know, just to show you that you can work with larger sets of values. All right. Now, normally I would go right to a print command if I'm going to print everything, but that's not what I want. What I want is the ones in the even positions. So I have to write an if statement to test for that. And I'm going to say if the values in position I, that will update dynamically. It'll start at 0. We take that and mod it by, okay, so that would make sense, would it? Yeah. Okay. So that would give me the even numbered values, right? So you guys are thinking, yeah, we just take it mod 2. Yeah, but that happens on the contents. We wanted to work on the index. So here it's actually a pretty simple command. So what we'll do is we'll just say values I. This will be our print command. And then in order to print every other value, that's built into the looping structure, by the way. So we have a little bit of a kind of like a cheat built in. But what it'll do is it'll print the value in whatever position, put a space, and then print the next one next to it, right? The cheat, you know, and it's not really a cheat, is we have in the range command available to us the ability to skip one built right into it, right? So we just drop a 2, a third parameter into the range function, and it will just start at 0 and do every other one. Why does it start at 0? Because we told it to, right? So that's kind of the solution for the first one. Not too hard, actually. I'm going to come back to the margin here and just enter a blank print command, which will, you know, separate this out. Let's run this and see what happens. Did it work? Okay. All right, so here's the list. And this is why it's helpful to output the list, even though you're not told to. It helps to see what's in there to confirm that your code worked, right? So this is position 0, position 2, 4, 6, 8. Are those the same numbers? They sure are. So we are pulling everything from even positions. Right. That's part 1. Let's try the next part. The next part is to display only even numbers in the list. All right, so with this one, the approach is going to be very similar. I do want to label everything. So I do have some pre-created content here. I'm just pasting in. All right, so we're only pulling the even numbers out of the list. Now, for that one, it's going to be really, really similar to this. So I'm going to just copy this code and just tweak it. The first thing that we're going to do is remove that third parameter in the range command because we don't need it. We do want it to go through every element in the list so we can see what it is. Right? And then in this situation, before I do the print, I do want to run an if statement. And here's where that mod 2 things comes in. So if the values in the given position, the one that we're currently looking at, if we divide that by 2, that has to go outside, by the way, and the result of the remainder is 0, so it's an even number, then we will output the information. Now, this print command is not sitting inside the if statement right now. You guys are noticing that, so I do have to tab it in one and move it over so it's part of the if statement. That should do it. That's all of it right there. Pretty simple. Let's see if it works. Here comes the run. We have a new list of values here, of course. All right. So now we're looking for just the even values. I mean, I can tell from the list, these are all even numbers. It didn't miss any, did it? It didn't, right? So I think that worked great. All right, let's move on to part 3. And the call on this one is all the elements in reverse order. Well, that's kind of an interesting call. All right, so here's my description. All right, we're labeling it so we know what we're looking at. And once again, we're going to use a loop. Now, watch the syntax on this one. This is kind of interesting. We can say for I in range, and then our parameter list here. And we need a beginning and an ending value. So this is where it gets a little bit weird. So when we look at the size of our list, the size of that list right now is 10. And this is why I did like the variable approach, by the way. We'll see this in a second. So I'm going to start with the number of ints. Okay, so that would put us in position 10. That's a problem, right? Why? Because there is no position 10. There's a position 9, which is the 10th position, but we start counting at 0, right? That whole thing. So I have to subtract 1 from it. So the starting point is whatever total we have minus 1, right? Then we are going to work our way down. So if you think about this conceptually, we're going to, count from 9 down to 0. So your thought would be we put 0 here, but remember in Python, we never reach that number. We have to go 1 beyond it, but we're going negative to minus 1. Yes, there is no minus 1 position, right? There's only a 0 position, but that's the syntax. And then we're going backwards. So we're incrementing negatively. So we're going down by 1. And there's the syntax. So it's the highest position in the list minus 1. We're going down to minus 1. We never reach it. So we stop at 0. And then we're going backwards. So minus 1. So there you go. Weird syntax, but it works. All right. Then basically all we're going to do is print the values. We already have a command that does that up here. So this traverses the structure in reverse order. Now, interestingly, I'm not changing the stuff in the list. I'm only outputting it backwards, if you feel what I'm saying. So this doesn't change what's in there. It's just, it's just kind of like sorting stuff backwards. Let's also add a blank print command here. And this is just once again to move stuff down to the next line since we're doing this end thing. All right, here comes the run. All right, so that's the original list here. Is this the list backwards down here? Yeah, it sure is. All right, pretty neat little trick. Really interesting syntax. If you know other languages, this is really bizarre, because not at all how you do it in other languages. And this is, I'm not sure if it's elegant or just unique, but it sure is seemingly a lot easier than some of the techniques we use in other languages to accomplish the same thing. So maybe it is elegant. Maybe it's kind of an elegant tool. All right. The last task is to display the first and last element specifically. And I'm going to kind of do that in a number of different ways here, because frankly, there's more than one way to do it. And so I think that this is helpful. So let's start with the print command. So I'm going to do print. We're going to use string interpolation here. So I'm going to put that letter F in there. And then we're going to say first and last items. That's probably enough. And then here in curly brackets, I'm going to say values square bracket 0. So what's that? That's the first position. Right? So there's the first value. And if we're going to pull in the last value, how do we do that? What's the syntax inside those square brackets for pulling in the last value? Okay, well, there's, like I said, there's more than one way to do it. So the first position, like extracting that information is just, hey, what's in the first position? Position 0. So that one's not going to change. But how you get to the last position is. And so the one technique we could use here is the same technique we used here, because the last position is position 9, remember, not position 10, even though we have 10 values. So we can just use that same syntax. So we can just say num int -1. So 10, index value 10, go back 1. And does that work? All right, well, first and last items, 54 and 14, that is correct. All right, what's another way to do it? Let's just copy this whole print statement. And this is really an attempt to kind of have you guys, really think about this. Now, in some cases, you might do this approach, right? So you might think about it, store it in a variable like this, but sometimes you don't do that. But yet the structure still exists, and there are ways to figure out how big a structure is. And we've already used this command, by the way, but instead of doing this kind of like -1 thing, what we're going to do instead is we're going to check how big values is in length. So it's going to test the length of values. It will come back with a length of 10, which is 1 too high. And then we have to subtract 1. So very similar, but if we hadn't done this, this would be the go-to to dynamically adjust to the size. So in other words, if the list had a few more things appended to it, this would dynamically adjust. This would too, but we're kind of hard coding it, whatever. This, I think for many programmers is maybe the default. Check the length, subtract 1, you're good, right? Now, of course, Python has, this really goofy, elegant syntax that it also uses where somebody's like, hey man, if we're always doing this length of values -1, can we like truncate that syntax somehow? And so what creators of the language did is they just did this. So if you put in an index value of -1, that means you're looking at the, whatever the last position is and subtract 1. And they just truncated it like this. So this one works too. So if I run this, you can see all 3 of them yield the same result. If you're asking me like which one I would go to for simplicity, I probably would use the last one. It's kind of the modern approach. There are reasons where maybe you wouldn't want to. All right. The other thing that I'll do, and I'm just going to do this for fun at this point because we're basically done with the exercise, is what if we change the size of the structure we're working with? Right now, we're working with 10 values. What if we made that, a bigger number? What if we made that 50? Now, because of the way that I, put that num int everywhere, and you see it highlighting now as I double click it, all of those spots will automatically adjust to 50. So all of my loops will automatically adjust. The random number generation will automatically adjust. All right, so I'm going to run this. Here goes. So now we're going to be generating a list of 50 values. Notice how quickly Python does it. It's just like, it's there, like super, super fast. So this is 50 values. And then I have like, these are my weird test prints, this stuff here. But knowing that it worked on a smaller list, and this is really the teaching point here for me, is, you want to test that these tools work. Well, don't do it with a list that's a million long to start with, um, because you don't need to, right? So a list of 10 is adequate to see if the tools are working. We've already confirmed that the tools are working. And so now when I take, this list here of 50 values between 0 and 100, I can trust that these items are all at even index positions, that these are all even numbers. That's an easy one to verify. That there's a reverse order. I mean, I guess I could check it character by character, but I'm taking it on faith. And that the first and the last items are 65 and 14, which indeed they are. All right. So, I'm not going to leave the 50 there, but you could, whatever. I'm just going to leave it. But that's exercise 6-1. I'd like to see how you guys all did here on this one. All right, we're going to move on to exercise number 2 at this point. So let's go back to that Word doc and get the instructions. It says, write a program that reads numbers and adds them to a list if they aren't already contained in the list. When the list contains 10 numbers, the program displays the contents and quits. This is kind of an interesting little problem. So I think you can see that there's some commonalities with what we just did. There's a unique aspect to this. So first, it says reads numbers. Okay, to me that says we're prompting the user. And you know what? There's no specific declaration here that says that it has to be an integer. A lot of times when we program, we're just doing an integer. No, who's to say, right? So we're going to use floating point numbers instead for starters. And we also have to check before we add that value to the list if it's unique, right? So if the user enters 1 and then enters 1 again, it's not going to be allowed. So we have to have a way to check to see if the value that we received is already present. So in other words, they're entering it, and then we look and go, is it here already? Oh, it's not. We'll add it. Oh, it is. Try again, basically. And so let's kind of attack that in a kind of a unique way. And I think we clearly are going to have to use a loop for this. But I'm going to show you that in this case, instead of using the for loop, which is kind of the go-to often, we're going to use a while loop, because the while loop does not run a specific number of times necessarily. It runs until a condition is met. And the condition here would be when the loop is, or when the structure is full. All right. So new program. Let's do a save as. Call this exercise 6_2. And if you want, you could copy the instructions in up here, just for reference. Doesn't hurt, like later on, if you look at your code, you know why you did it. I'm also going to throw this comment in here at the top. Right, I'm using standard Python commenting format. Maybe being a little verbose. Once again, I'm going to do the variable technique that we did last time. And I'm calling it number of ints, but maybe number of nums is better. And what I'm thinking here is, like, we were told to do 10 unique values, but once again, we could make it much larger, and this would be the spot where you would control it. So we'll preset this to 10. All right, so that's kind of the why, right? So we can try bigger values once we get it to work this way by just changing this number here, right? So once again, you could say optional, not required, but I'm just doing it because I think it's a fun way to proceed. Right. The next thing is kind of the command from above. So I'm just going to paste that. Read a collection of values from user, adding each to the list if it's not already present. So, all right. Well, you know what? We need a list. So let's create one. Let's use the same name we did before. We'll just call it values, square brackets. It's an empty list. Now will come the while loop. So now comes the thought, okay, how long do we run this? And how do I declare that as a condition for a while loop? All right, well, how many values are we supposed to do it? For right now, 10. So basically, we want to find a way to figure out if how many values we have currently has reached 10. All right, so if you think about how you might code that, how do I know how big the list is currently? Well, here I use the length function. So I'm just going to test the length of what we have. And if I have nothing in there, it'll be 0. If I have a couple numbers in there, it'll be 2, right? And while that is less than the number of nums, I like how I named that. So if it's less than the number of numbers that we want, we'll keep going. Notice I'm using less than and not less than or equal to here, because what is the length, right? Right. So in other words, if we do hit 10, we want it to pop out. We don't want to do it one more time. So what'll happen each time? Now, have you guys noticed we haven't prompted the user yet? Right. So most of the times when we've run programs like this, our prompts are at the top. Here, the prompt makes sense to be inside the while loop each time. So they only see it if this condition is true. When we start the program, of course, that condition is true. The length of values is less than 10 for sure. All right, so what'll happen in that situation? Well, let's set up a variable. I'm just going to call it X, whatever. We'll prompt the user and say something really complicated like enter a number. Now, that'll capture it as a string, right? Now we had this conversation before. Do we want it to be a string or do we want it to be a number? We definitely want it to be a number, but do we want it to be a regular integer or a floating point number? The prompt is vague, so they could type a floating point number. So I would contend that we want to convert this to a float to be on the safe side. So they could type an integer, that'll be fine. They could type a floating point, we'll be fine either way. So now we need to check the number that they just entered. Is that already in the list? So that sounds like an if statement to me. So I'm going to say if, and watch the syntax on this. This is kind of interesting because we've done stuff in the past where we've looked at if like a character is in a string, then we can trigger something true. But we're looking to see actually the opposite. We want to append the number to the list. So we only want to execute the append, function if X is not in values. And I love this syntax because once again, when I compare it to other languages, man, it just reads like English, right? So if X is not in values, which is our list, go ahead and do the append. And the append command is really simple. We would just say values append X. Right? That would add it to the list, but only if X is not already in values. And I think that's awesome. It's just so simple, right? Is there any more work we need to do here? Will this stop automatically after 10 tries? You know what? The only way we know is to try it. We need to know if it worked, right? So how do you know if it worked? Well, there's a couple things going on here. So normally I'm not a big user of these auxiliary panels up here, but when we start running the program, this panel will show our our list and the values in it as we're going, so we can actually see it filling up, right? Um, but otherwise, you know, we're gonna have to display the values to see if it actually works. So we're gonna do that after the fact, but you can always keep your eye on the panel up here to keep track as we go. We're just gonna do a really simple print command here. So let's do print. Let's do it with string interpolation this time. And we'll say the numbers entered are, here's my curly brackets, and we're just going to output the whole damn list. Like so. Very simple. All right. Let's save that. And we're going to hit the run button. All right. Okay, now keep your eyes up here, you know, as we start to enter stuff. So I'm going to type 1. And of course, it's not refreshing. That's kind of blows the whole fun of it. There we go. All right. Now notice, you know, I hit the little refresh button, by the way, and sometimes I forget to do that. But if you look up here, it is indicating, right, what X is, what the values are. And notice, even though I typed an integer, it converted it to a float. Why? Because I told it to, right? So let's keep entering numbers then. And I'm going to be kind of silly about this, right? So we can always do a refresh there. And I did really basic numbers in a sequence like that because, you know, they're easy to look at, easy to keep track of it while I'm typing, you know, all of that, right? So that worked. It took 10 values, right? Um, Converted them to floats and put them back up on the screen. All right. But let's try the other aspect of it. I consciously made the choice to put different values in. That might not have been the case. So I'm instead now, when I do it this time, I'm going to be a little bit more random with it and intentionally put in values that I've already added before. So let's run it again. Scroll here. And so I'll type 2, 2, 3. Let's refresh this up here. See, only captured 2 and 3. Right. 4, 2.3, 2.1, 2.3, 2.3, 2.3, 2.3, 2.3. Well, that was kind of interesting. Let's see what that did. Right. So right now we have 5 values. And then, you know, you can type whatever, but you know, the whole point is not to type a string like I just did and make it crash. All right. Yeah, you could write code to prevent that from happening. Well, so I had an epic fail there by just accidentally hitting the keyboard. Let's run this. Let's, I did it again. I'm trying to do it fast, you know, and that's kind of a little lesson right there. Don't try to do it fast. Take your time and make sure it works. You know, because I do want to see your output too, and like what you tried. That's kind of an interesting one, isn't it? Right? Is 1.0 the same as 1? Well, according to this, it is because that 1.0 did not get added. And then I don't have too many left to go here, so I'm going to be really careful so I don't crash again. All right, so it took me a little bit there because I did have some intentionally repeated values, but this is working. Uh, Hopefully, it's working for you guys too.